Jai Hind everyone. My name is Ritesh Sharma. I am from AKGEC Engineering College, Ghaziabad. So the subject which I am taking is the Fundamental of Electrical Engineering. This is the course which is taught in the first year, and the subject code is BEE101. So today I am going to take a very important topic. The topic is mesh and nodal analysis. So we know that in the first year, the basic electrical subjects, the some important topics which are generally in the DC circuits, which in the DC circuits, not in the AC circuits. So this mesh and the nodal analysis is one of the important topics, which is basically important or to simplify or to solve the circuit, DC circuit. Okay, so let us start with the lecture or topic. So you can see that in this topic we have the mesh and loop analysis. So this first we take the case of the mesh and loop analysis. In this mesh and loop analysis, and first of all we have to understand what is the difference between the mesh and the loop. The mesh is the, you can say that is the smallest loop in our circuit, means inside mesh there will be no loop. So mesh is the smallest loop of the circuit. Okay. Now to understand this particular mesh and loop analysis, just this mesh and loop analysis is basically based on the Kirchhoff voltage law. We all know that what is Kirchhoff voltage law? That is the algebraic sum of the voltages in a particular loop or in a closed circuit is 0. This is the Kirchhoff voltage law. Now let us understand how this technique will use to solve the circuit. Okay. So first of all, let us to understand this mesh and loop analysis, let us take a simple circuit. Let us take a simple circuit. I have taken a circuit. In this circuit we have a R1, R2, R2 and R3 are the three resistances. Okay, and E1 and E2 are the sources, or the DC sources are there. Okay, so in the mesh and the loop analysis, we have to consider the mesh current. That is, we have to consider the current in a mesh. So in this circuit we have the two meshes. This is mesh number 1 and this is mesh number 2. Okay, we have two meshes. So this means we have the two mesh currents are there. So we have assumed that I1 and I2 are the current which is circulating in this mesh in clockwise direction. We can take in clockwise or anti-clockwise in any direction, but here we have taken then in clockwise directions. So now, so first of all, to solve this circuit, we have to find the value of I1 and I2. If we can find the value of I1 and I2, we can find the value of any voltages or the voltage in any branch actually, or the current in any branch actually. So first of all, let us take the we have two meshes. So first mesh is the, suppose that the mesh A, B, D, A. So A, B, D and A. So let us consider the first mesh in A, B, D, A and apply the Kirchhoff voltage law. When we apply the Kirchhoff voltage law, we will start it from the A point and then it will go to the, since it is a mesh or the loop, so we will apply the KVL in the whole this closed circuit. So it means that the current will flow like this. It's I1. So this is a high potential, this is low potential. So the voltage drop will be there, that is I1 R1. Minus 1 means there is a drop in the voltages. Similarly, when it will go to this particular path from B to D, the current is I1 and I2 is also flowing in this branch, since the branch is common to both the mesh. So I1 and I2 is the effective value of current and the resistance is R2. And then if we move from D to A, there is a rise in the voltage, so plus E1. Okay, so let us rearrange these terms. We will got I1 R1 plus R2. This is our first equation number 1. Equation number 1. So from mesh 1 or from this particular mesh, we will get the one loop equation. This is equation this. Now let us come to another mesh B, C, D, B. B, C, D, B. In this particular mesh B, C, D, B, again we apply the same the concept of KVL, because the current is flowing like this. So from B to C there will be a minus I2 into R3. Okay, minus the current will flow, this is plus, this is minus. So there is a drop in the voltage. So minus I2 into R3. Then here again there is a drop, this is plus, this is minus, since so this is the minus E2. Then in this again this is the common branch and the current is going like this, the I2 is going like this, and then the effective current will be I2 minus I1 into R2. So this is the current equation or the loop equation of this particular loop. And then when we rearrange this, we will get this current, this value of, this is our second equation. Let us assume that it is the equation number 2. So we have the two equations in terms of I1 and I2. So two equations, two variables, we can easily solve them, and then we will get the value of I1 and I2. Okay, when we have the value of I2, I1, I2, we can find the value of any current in any branch actually. So this is the basic methodology which we use in the mesh and loop analysis. Okay, now let us solve one numerical based on this mesh analysis. So we take an example of calculate the current in each branch of the circuit shown. So we have to find the value of current in each branches in this particular circuit. Now this circuit, you can say that we have 1, 2 and 3 meshes, because this is a mesh. So let us assume that this is mesh number 1, mesh number 2, and this is mesh number 3, and let us name them. Okay, node, these are the nodes which are there. So let us take the number A, B, C, D, E, F, G, H, like that, and one by one we will solve them. Okay, so first of all take this mesh, this particular mesh is B, H, G, A. So first we take the A, mesh A, B, H, A, B, H, G, A, B. So this is one of the first mesh that we have taken, and we apply the KVL in this particular mesh. So what we found, let us start from the point A. So minus 60 I1, minus 60 I1, since the current is I1, this is high potential, this is low potential. Current always flow from high to low potential. So minus 60 I1, minus 30 here, this is plus, this is minus 30, but this branch is shared by this third loop. So effective current will be I1 minus I3, I1 minus I3. Then from H to G, you can say that at this point we have 50 ohm resistance here, current is going this direction, and the current is shared by this, so I1 minus I2, plus minus, that means there will be drop in the voltage. So minus 20, and then plus minus plus, rise in the voltage, plus 100. So when we solve this equation, we will find that this is our equation in terms of I1, I2 and I3. That is 14 I1 minus 5 I2 minus 3 I3 is equal to 8. This is the first equation which we will get from the loop number 1. In the similar way, we will apply the KVL in the second loop. In the second loop, that is the loop or the mesh which is GHEFG. GHEFG. So this is the again second loop. Again we apply the Kirchhoff voltage law in this loop starting from this G. So minus, since it is we are going in this clockwise, so this is plus, minus, this is plus, so plus 20, that is the rise in the voltage. Then at this point this is plus, this is minus, the drop in the voltage minus 50, current is already we know that the I2 minus I1, this branch having I2 minus I1. Then minus 40, this branch, this is my plus, this is minus, so minus 40 I2 minus I3, because it is shared by with the loop number 3, plus 10 I2, this is the 10, and the current is flowing is I2, plus 50, so this is minus, this is plus, plus 50. After solving this, we will get this minus 5I1 plus 10I2 minus 4I3 is equal to 7. This is the second equation. So, first equation and second equation. So, now we have, since we have the 3 loops, so we have 3 loop currents are there. So, if the 3 loops current are there, we need the 3 equations actually to note the 3 equations, 3 variables, since we have 3 variables. So, for the last loop, the third one, we have the B, C, D, E, H, B. So, this is our B, C, D, H, B. So, again we apply the KVL, similar process. So, B, C, D. So, we started from this. So, this is plus, this is minus. So, minus 20I3, minus 20I3. Then here this 40, since this is plus, this is minus, because we are working in the third loop and the current is moving like this. So, this will be plus, this will be minus. So, this minus 40 I3 minus I2, I3 minus I2, effective current in this, and then 30 I3 minus I1. So, this particular branch will shade with the loop number 1. So, 30 I3 minus I1. So, this is the loop current equation. So, after solving, we will get this equation in the simplified form, that is 3I1 plus 4I2 minus 9I3. So, we have 3 equations, equation 1, 2 and 3. So, 3 variables, we can solve it by using calculators, or we can also use some Cramer rules, or 3 equations, 3 variables, we can solve it, and by solving we will get this answer I1, I2 and I3. So, I1 is 1.665 ampere, I2 is 2.12 ampere, and I3 is equal to 1.5 ampere. These are the current, the values of the current, or the loop current actually. These are the loop current. Okay. So, we have to calculate the current in each branch. So, for each branch, you can calculate the current in every branch because of the circuit. Okay. So, the current in 60 ohm resistance, what is the value of current? In 60 ohm this. So, we know that the current is I1. This branch carries current I1 minus I3, sorry. This branch carries current I1 minus I2. This branch carries current I2 minus I3. So, depending upon the what value of current is this, we can actually find the current like this. So, I1 minus I2, 3, I2 minus I1, I2 minus I3, and in 10 and 20 ohm is I2 and I3 respectively. So, this is how we can calculate the value of different value of current in different branch actually. Okay. So, this method is very important or easy to understand to find the value of current in any branch, or if we have the value of current of any branch, we can easily calculate the voltage drop in a particular branch. So, this is the technique or method that we can use. So, again this is one of the another examples of the mesh current analysis, or to find the current in the different branches using the mesh current analysis. So, how will you solve it? First of all, so in this branch, suppose this is the I1, I2 and I3, 3 currents. So, we can see that we have the 3 branches, or 3 loops are there, or 3 mesh are there. Okay. So, we can find the current, we have to find the current in every, this loop current is this. But now in this case there is a one issue, there is a one limitation of this, that if any branch in any, if there is a current source, which is shared by the 2 loops or 2 mesh, then we cannot apply the KVL in that. So, this is basically the case of super mesh. This is the case of super mesh. In this case, super mesh, it is very difficult to apply the Kirchhoff voltage law, because we don't have the resistance of this source actually. So, that is where we have to avoid the KVL in that mesh. Okay. But it is this particular source will give us some value of current in that branch also. Okay, so let us take this example of find the value of current I1, I2 and I3. So when we apply this in this case, we know that the current I1 is flowing in this particular, like this, I1 is in this loop, and I3 is flowing in like this. So it means that the effective current through this source is going downward. It means that the value of I1 minus I3 is automatically will be equal to 5 ampere. This is my first equation that I can assume, because this source is the value of the source, it is a current source, the value of the source is 5 ampere, and this will be equal to your I1 minus I3 is equal to 5 ampere. Okay, now let us apply the Kirchhoff voltage law in second loop. In second loop, suppose the current is going like this. Okay, if the current will go like this, so this 1 ampere is this, the 1 ampere means minus 1, since I2 is this, so I2 minus I1 minus 1, then this is minus of 2 I2, then this minus of 3 I2, and it is shared by I2 and I3. So I2 is going this way and I3 is going this way, and we are moving from here to here. So it's a drop in the voltage. So it is I2 minus I3 equal to 0. Since there is no current source in this, so we can apply the KVL in this second loop. Okay, in second loop. So we cannot apply the KVL in the first loop, we cannot apply the KVL in the second loop, but we can apply the KVL in second loop. Okay, in first and third we can't, because there is a presence of current source. Now we have two equations, one equation from this and one equation from this, but we need one more equation to solve this particular circuit, because this we have three equations. So three unknowns are there, I1, I2 and I3. So that means there will be one more equations. How will we get this one more equation? Because we have to avoid this current source. So we can apply, we can write the KVL for, we can write the KVL for this particular a bigger loop. Okay, but because we can't apply the KVL in this and this, and we already applied the KVL in this loop, mesh number 2. So now for the third equation we will apply the KVL in this loop. Okay, so in this third loop we can name it like this, third one. So if you start from here, this is minus, this is plus, so it is 10. In this branch we have a minus 2, current is I2, and this we have minus 1, current is I3, and then this is equal to 0. So 10, 2 into I2, 1 into I3, and then in this loop, suppose that it is A, B, C, D. So in this A, B, C, D we have this value of current, that is 10 minus 2 I2 minus I3 is equal to 0. So that is equal to 2 I2 plus I3 equal to 10. Name it equation number 3. So 3 equations, 3 variables, you can solve easily, and these are the answers. These are the answers. When you calculate, you will get this. Just simplify these 3 equations. So this is the one of the important case when there is a current source is there in a particular mesh. Okay, so then it is very difficult for us to apply the KVL. So to avoid that, we need to just eliminate that loop, and then we can apply the KVL in other loop also. Okay, and the rest of the process is the same. Okay, so as many as the loop are there, so as many as a mesh are there, or the mesh equations are there, we can solve it. Okay, now this is one of the another questions. Example 3, find the current in the 40 ohm resistance. Find the current in the 40 ohm resistance using the mesh analysis. So in this particular branch, you have to find the current actually. So we can see that we have the 3 loops are there, 1, 2 and 3. So let us suppose that this is a loop number 1 having current I1, loop number 2 I2, and again the loop number 3 I3. Clear? So we just assume this. Since we have a mesh, 3 meshes are there, 3 meshes this, so 3 equations are there. Now, while looking at this network, we can see that there is a current source is there. So current source is in the third mesh. So it means that the value of I3 by seeing, so value of I3 here is equal to, since the current source value is going in this direction, so I3 means -1, because I3 what we have assumed in the clockwise direction, but current is going opposite to that. So I3 is equal to -1 ampere. -1 ampere. Now apply the KVL in this is the first loop, first, second, and this is our third one. Okay, now let us write the loop equations in first. Suppose the current is going in these directions, so apply the KVL in the first loop, that is -10 I1. Then from this branch it is minus, so since it is plus, it is this is minus, so minus of 40 I1 minus sorry, it's 2, I2 is this is I2, I1 minus I2. Okay, now this is minus to high to low potential, low to high potential, that is minus of, sorry, plus, minus to plus, that is voltage rise is this, so plus 5 equal to 0. So time minus 10 I1 minus 40 I1 plus 40 I2 plus 5 is equal to 0, So 10 minus 50 I1 plus 40 I2 is equal to minus 5. This is one equation. Assume that equation number 1. Now apply the in second loop. Apply KVL in second loop. In second loop, let us start from this x, y, and like this point. So in this particular part, when we apply the KVL second loop, starting from the x, so minus 16, the current is I2 is there, I2. Minus 8, this is 8 plus 2 minus 8, I2 minus I3. So I2 minus I3. Then we come to this branch, this is plus, this is minus, because we are talking in terms of this loop. So the current is, this loop is going in this direction, so this will be plus, this will be minus. Okay, so this is minus 40, the current is I2 minus I1 equal to 0. So you can solve it, minus 16 I2 minus 8 I2 minus plus 8 I3 plus minus 40 I2 plus 40 I1. This is minus 40 I1 is equal to 0. Now again we can solve it here. Okay, so we have 40 I1, this, so 40 I1 minus 16 I2 minus 16 minus 24 minus 24 and minus 40 minus 64 I2, then we have 8 I3 and equal to 0. So this is equation 1, this is equation number 2. 1, 2. In third loop we have already this equation I3 is equal to, so we can put the value of I3 here, that is minus 1. So this will be converted as I1 I2. Similarly we have this equation I1 I2. So that means this equation is equal to, now will be 40 I1 minus 64 I2, and this is minus 8 into minus 8 equal to 0. This is the second equation. Substituting I3, substitute I3 is equal to minus 1. तो यहाँ से आगे इसको पुट किया हमने, we will get this equation. So now we have two equations, 1 and 2, two equations, two variables, so we can solve it accordingly. So this is the method or the procedure to solve such network. Okay, once we have this value I1 I2 I3, we can calculate the current in every. Here it is required to find the current in 40 ohm. So in 40 ohm, how much current flowing? It is I1 minus I2. So once we have I1 I2, you can calculate I1 minus I2. So that value will be the answer. So this is the solution. Next technique which we are going to study is the nodal analysis. In nodal analysis, it is just like a KCL, because in nodal means node, and at node we know that the algebraic sum of all the current at a node is equal to 0, or in other word, the sum of the incoming current is equal to outgoing current. So let us to understand this nodal analysis, we have to understand a simple circuit, then we will solve it. So we can see that this is one of the simpler circuit, and having the node B and C is there. You can see the node A, B, C, D, E, but B and C are the effective node where the two or more or branches are connected here. Okay, this. So let us, first of all, we have to assume the current in every branch. Suppose that the current in this branch, E1 is a source, one of the source, and at this point or this node B, the current I1 plus I2 is equal to 4. So I1 is coming here, I4 is going just like this, and I2 is from C to B. So at point B, I1 plus I2 is equal to I4, because incoming current is equal to outgoing current. Okay, that is simple Kirchhoff's law, Kirchhoff current law rather. Okay, so this is the at B. So I1, what is I1 here? The I1 is current flowing in this direction, and current always flows from high to low potential. So this E1 and V1, this, suppose this B has some voltage called VB, and this node has some voltage VC. This is VB, this is VC. So it means that the current I1 will be equal to, the current I1 is equal to high to low, this voltage E1 minus this voltage VB upon the resistance between the two, that is R1. This is the R1, this is the I1 actually. Okay. Similarly, I2 is the thing, but coming from this. So VC, so I2 is this, E2 minus VB, or you can say VC minus VB, and this is minus this plus. So just having the, we will add V2 in E2 in this. So VC plus E2 minus VB upon R2 is this. So this is I2, and I4 is coming from this. This is VB, and this is at the zero potential because it is reference. So all these nodes are connected reference or grounded. So this is I1, this is I2 is equal to I4. So I4 is equal to VB upon I4. So we put over there, we will get equations in the form of equation in VB, in B and VB and VC. Similarly at C, at node C, so we have to analyze a node actually. So at C, we know that the I3 is equal to I2 plus I5. The I3 is coming from here. This is I5 and this is I2. So I3 is equal to I5, I3 is equal to I2 plus I5. So what is I2 again? So I2 again is this current. So E2 minus VB, whatever we have done over here, is I2 plus I5, that is VC upon R5 is equal to I3. I3 is coming from here. So this is high potential. So E3 minus VC upon the resistance is R3. So we have to apply these two KCL equations and convert it into the voltage equations, voltages of their nodal voltage, and then we will solve them. So from this equation number 1 and 2, suppose this is equation number 1, we will get one equation, this is equation number 2. So from these two equations, we can find VB and VC. We can calculate or we can find the other quantities or any value of current in any branch. Okay, so we can find any branch current. So this technique is basically based on Kirchhoff current law or KCL, okay, or nodal analysis. So let us apply this technique to solve any numerical. So suppose this is the method or the question in which we have to find the current in the various resistances using the nodal analysis. So by seeing the circuit, we can say that we have the three nodes. Suppose this is A, this is B, and this is C, and this one is called bottom node. Bottom node having zero potential actually or grounded. Okay, so this circuit can be assumed or can be redrawn in this way actually. Okay, so this is how the current distribution is shown to us. This is a 10 ampere current source, this is a 2 ampere current source, and assume that this is the I, this is I1, this is I2, this is I3, this is I5, this is I4, and this is I6. So this distribution of the current, we have to assume it. We can assume it in any direction depending upon our convenience. So on that basis, we will find the we will apply the nodal at 1, 2, and 3 equation. So mind it one thing, as many as the nodes are there, the node equation will be there. It means that we have 3 nodes, so we have 1, 2, 3 node voltages. That means we have 3 equations will be there. So first of all, we apply the KCL at node number 1. So at node number 1, I is equal to I1 plus I2 plus I3. So we can apply this I1 plus I2 plus I3. Then we just convert it into the voltages. Converted into voltages means whatever voltage of this volt 1, 2, and 3. So suppose we have assumed that V1, V2, and V3. Okay. So we just find that I1 is nothing but this coming from here. So I1 is equal to 10 ampere. Just 10 ampere is this. I1 is V1 by 2, I2 is V1 minus V2 by 2, and I3 is this. So these are the potential of these. We know that. So just substitute these values of the current in the form of voltages and we will get the equations, this equation. Similarly for the second node. In second node, again we have I2 is equal to I4 plus I5, this. So convert into voltage equation this and then solve it, we will get this equation. So equation 1, equation 2, and then equation 3. And then if we will solve it, we will get these value of currents. So this is the method. Once we have V1, V2, V3, we can calculate the current in any branches actually. So this is the method, we called it the nodal. So since these two techniques are very important and can solve the network easily, so it is very important to understand these two techniques. In the next lecture, we will discuss more problem with this nodal and mesh analysis. Thank you so much. Jai Hind.